It's incredible. Once again, the James Webb Telescope presents us with an image we've all been waiting for. NASA has finally released the first images of planets so strange that they defy our old ideas of life in the universe. 2007 OR10 is a dwarf planet hovering at the very edge of the solar system, showing mysterious signs of life in the utter darkness of the Kuiper Belt. Will we discover life on this world for the first time in the universe? 2007 OR10 is a scientific miracle. Researchers would never have expected to discover another planet of this size so far out in our own solar system. Since its first sighting in 2007, this dwarf planet has attracted the attention of the scientific community. With a diameter of around 1,535 kilometers, it is one of the largest known dwarf planets in our solar system. 2007 OR10 shows traces of a surface rich in complex organic compounds. This world was discovered by astronomers using the Samuel Oskin telescope at the Palomar Observatory. Its slow rotation of around 45 hours and its isolated location in the Kuiper Belt make it one of the most enigmatic objects we know. Now scientists want to use their new wonder weapon to get to the bottom of the planet. The James Webb Telescope is virtually predestined to analyze a distant and almost dark world like 2007 OR10 in great detail. James Webb misses nothing. Who would have thought that a single technical tool could revolutionize our entire world? Among experts, James Webb, the new space telescope, is already considered a legend. Yet the telescope is nothing more than a stroke of technical genius that we humans have constructed over decades of painstaking and ingenious work in order to finally unravel the last great mysteries of the universe. This most powerful telescope of all time has cost $11 billion, and we already know that this instrument is worth every single dollar. Since its launch in the summer of 2022, the telescope's first images are overturning everything we thought we knew. The Big Bang is under scrutiny. Our theories of the formation of matter and the evolution of galaxies were very, very likely wrong. We have to completely rethink the age and the finiteness or infinity of the universe. Webb showed us galaxies so old and so perfect that they could not possibly fit into a young universe. We saw images of black holes that were so huge and large at the dawn of time that they could not possibly exist according to our old astrophysics. We now have to rethink and open ourselves up to a completely new worldview. Planets like 2007 OR10 were already something of a warning to our science. We are far from knowing everything, and since the launch of Webb, we have had to realize more and more how little we really know about the universe. James Webb surpasses all previous telescopes with its outstanding technical capabilities. With its huge 6.5 m primary mirror and state-of-the-art infrared instruments, Webb can look into the deepest and most distant regions of the universe. Its extraordinary sensitivity enables it to reliably detect light sources that are 13.5 billion years old, almost as old as the universe itself. Webb can see through dense dust clouds that block other telescopes, revealing hidden stars and planets. This ability to observe the universe in unprecedented detail makes the James Webb Telescope an invaluable tool for astronomy, opening doors every day to discoveries that will fundamentally change the way we think about the cosmos. What will Webb find on 2007 OR10? Imagine the JWST pointing its high-precision instruments at the mysterious dwarf planet 2007 OR10. With its advanced infrared sensors and spectroscopic instruments, Webb could analyze the composition of the surface of this distant celestial body in unprecedented detail. Using its near-infrared spectrograph and mid-infrared instrument, Webb would be able to identify the chemical fingerprints of the materials present on 2007 OR10. A possible spectrometer image could provide us with fascinating insights into which complex organic compounds are really present here and what story they will tell us. Researchers suspect that the unusual coloration of the planet is due to these traces of these compounds became visible through the interaction of ultraviolet light with methane and other simple organic molecules. These are of particular interest for astrobiology, as they are considered to be building blocks for more complex organic molecules and would therefore be a basic building block for the development of life. Substances such as these have already been found in the vicinity of several moons in the solar system, which are also hot candidates for the first discovery of extraterrestrial life. Their presence on celestial bodies such as 2007 OR10 could indicate that the moons and dwarf planets played a previously unknown role in the origin of life in the solar system. These compounds could give us clues about how organic material forms and evolves in the outer solar system, and we gain important clues about the chemical and physical conditions in the early solar system. In addition, Webb could confirm the presence of water ice and other frozen substances that indicate the geological and climatic conditions on the dwarf planet. In addition to these incredible traces of life, 2007 OR10 has another secret concerning its very existence. The planet's orbit has not yet been fully confirmed, which is why it does not have a proper name and is only listed with a provisional catalogue number. So far, the details of its exact orbit and physical properties are truly shrouded in mystery. 2007 OR10 is so far away from us that observation with previous telescopes was only possible under very difficult conditions. Webb could be of decisive help here. Through precise observations and long-term monitoring, the telescope could determine the planet's rotation period more accurately and precisely track its orbital movements in the Kuiper belt. This data would be essential to calculate the orbit of this planet with greater accuracy, and once the criteria of the International Astronomical Union are met, the planet would finally get its own official name. Webb on the trail of the mysterious rogue planets. Have you ever heard of rogue planets? These objects are free-roaming planets in space and, like 2007 OR10, they are extremely difficult to study. In the infinite vastness of interstellar space, the planets are downright tiny, but they do exist. This has been proven beyond doubt. Sometimes researchers succeed in detecting these planets, but as soon as they are captured, they elude observation again because they disappear into the vast darkness of the universe. The James Webb Telescope has the ability to detect and study even these elusive planets. Webb's sophisticated infrared instruments can detect even the low thermal intrinsic radiation of rogue planets. These planets have no light source of their own, and they move outside the luminosity of stars. Yet even these planets emit a minimal amount of radiation due to the processes within them and their movement through space, which we can detect using advanced instruments such as Webb's. This tremendous advance will allow scientists to analyze the properties and compositions of these free-floating planets for the first time, and thus better understand the formation history of free-orbiting planets. Webb could help to determine the number and distribution of rogue planets in our galaxy. Researchers suspect a certain regularity to these phenomena. If we know how often and in which region of the universe the phenomenon occurs, we will have added another piece of the puzzle to the overall picture of our cosmology. Thanks to Webb and his precise analyses, we could uncover the internal structure and even possible geological activity of even the smallest thermal emissions from 2007 OR10. Wandering planets showing signs of geologic processes and active cores would be another miracle of science. The universe has shown us time and time again since we began exploring it that impossible does not exist. Cool ultra-hot Neptunes. We all know Neptune, the deep blue and rather cold ice giant at the outer edge of the solar system. But have you ever heard of ultra-hot Neptunes? Again, we have a fascinating new and truly unusual class of exoplanets that we would never have discovered without our immense advances in observational technology. These planets are similar to Neptune in composition but orbit extremely close to their stars, often much closer than Mercury orbits our Sun. Because of this proximity, the surfaces of these Neptune-like planets reach incredibly high temperatures. At over 1,700 degrees Celsius, these planets can be true horror worlds. These extreme conditions lead to many other interesting phenomena and turn existing theories about planet formation and evolution completely upside down. Ultra-hot Neptunes have such a hot surface that they can split gases such as hydrogen, helium, and methane into atomic components. These extreme temperatures can lead to atmospheric escape, where the planets lose their gases due to the intense radiation and strong stellar winds. A notable example of an ultra-hot Neptune is KELT 9b, whose temperature is so high that molecules such as water cannot exist in a stable form and instead break down into atomic hydrogen. The existence of ultra-hot Neptunes turns our old theories of planet formation upside down because, according to our conventional theories, such planets should not exist. They would have to be destroyed during their formation or by their extreme proximity to their stars. Their observation, therefore, challenges our understanding and forces scientists to develop new models and theories. These planets offer a unique opportunity to study the mechanisms of planetary migration and atmospheric escape under extreme conditions. The James Webb Telescope is now playing a crucial role in the study of ultra-hot Neptunes. With its sophisticated infrared instruments, Webb can also analyze in detail the thermal radiation and spectral signatures of these planets. Webb can examine the composition of the atmospheres and determine which molecules are actually present or absent in the environment of ultra-hot Neptunes. This data is crucial to understanding the chemical processes that take place under such extreme conditions. Using infrared spectroscopy, Webb easily penetrates the atmospheres of these planets and identifies the specific chemical fingerprints. This allows scientists to map the distribution of elements and molecules and study the effects of intense stellar radiation. Through long-form observations, Webb can not only monitor the atmospheric losses of these planets in detail but also better understand the mechanisms of planetary migration. If we know more about the rate and extent of atmospheric loss, we can understand